Today's video will demonstrate how to implement the four different command passing design patterns. Hello, I'm James Helfrich. There are four fundamental ways to pass a command from one part of the program to another. The first, direct invocation. The second, delegate. The third is command, otherwise known as encapsulated. And the fourth is interpreter. This video will demonstrate all four in the context of the game of Sudoku. So whenever we're talking about passing an order or a command from one part of the program to the other, there is always three parts to the equation. The first part is the commander, and this is who initiates the order. This is someone who requests something to get done. The second part is the executor, and this is who receives the order and then carries out the action as specified by the commander. And the final part is the order itself, and this represents the task which is to be accomplished. Now, the default and the most familiar method to do this is called direct invocation. And here I'm going to have the different parts of the program represented by A, B, C, D, E, F, G, and so on, is going to directly order the executor to do stuff by calling a function in that area. So let's take a look at the game of Sudoku. So we're going to focus on the bit between interact and the four different commands: display options, display board, edit square, and display possible moves. So how are we going to implement this in C++? Let's take a look at the source code. Okay, so here is my interact function in Sudoku. Depending upon the option that the user selects, I will either execute display options, display board, edit square, or display possible. This is an example of direct invocation. In other words, the commander directly calls the function as specified by the function name. And of course, the neat thing about this, it's very simple. All languages have function calling built in, but the disadvantage is this is done synchronously. In other words, first I call the function display options before control returns back to interact. Second problem is I really have no way to do undo or redo or have a history of the things that I've done. I'm just going to directly call the function. And really, for most scenarios, this is fine. So we have another option. We call this delegate invocation. And delegate invocation is the process of passing a function to another component, which will execute the function at the appointed time and the appointed context. And these functions are called delegates. So I have the commander and I have the executor. And of course, I'm going to have a connection between them. And that connection is the method of passing the order. And this order will come as a function parameter. And now the different parts of the commander, we're going to create the order, which is a function pointer, and then send it off to the executor. So let's take a look back at our Sudoku design. And so when we add the delegate, we're going to have an execute command, which is the execute the function for us. And it's going to then call display possible and display board and display options on behalf of interact. But how is it going to know which one to call? Because the order is going to be sent as well as the board, which is going to represent the context. So let's see how that works in Sudoku. Okay, so on the left here, we have the original code with direct invocation, and on the right, we have the delegate. The big difference here is the order, and the order is a function pointer. Now, this is a very odd way to declare a variable in C++ because the variable name is kind of embedded in the middle, and the syntax, frankly, is disgusting, but this is what we're given with C++. The important thing to note is this is a pointer of a function that returns a void, and the function takes a board as a parameter. And what I'm doing is I'm sending the order to display options if the user hits question mark, display board if I hit D, edit square if I hit E, and so on. And this very much is analogous to what I did originally. And the big difference is I had to make sure that every function takes the same prototype because every order must take a board as a parameter. Display options will just simply not use it. And then I'm going to have the executor who is going to actually call the function, and this executor says, look, if it's not the null pointer, then execute it using the board as a context. And so now back to our structure chart, you can see that interact is going to call execute, and execute will then call the various functions depending upon which order is passed. Okay, our next possibility is called encapsulated invocation. Now, encapsulated invocation is the process of passing an object to another component. And this other component will execute the predetermined method at the appointed time and in the appointed context. This design pattern is called encapsulated invocation because all the information necessary to perform the action is encapsulated in the sent object. It is also commonly known as the command design pattern. So going back to our commander and our executor, and they're going to be connected by passing the order, except this time the order is not going to be passed as a function pointer, but rather as an object. And then the different parts of the commander will formulate this order object and then send it to the executor, who will then execute the appropriate function. So moving back to our original design here, the difference here is now we're no longer have a function pointer, but rather our order is going to come across as a object. And then we're going to call this class order. It's going to have an execute command. And then there's going to be several different variations for display or order edit or order possible or whatever. Now notice order edit and order possible need the board as an attribute, but order display does not. And so when I create the order, I'm going to give different information according to the needs of that order. Okay, so let's take a look at the code now. So we have my interact in my delegate, which is going to create a function pointer, and we have my interact in my encapsulated, where my order is an object. In my function pointer, I just pass a pointer to the function to the order. Here, I'm going to create a new order. Now for the show options, then I'm just going to create an order with a default constructor. With the display board, I need to pass the board as a context. For the edit square, I need to pass in the board, the coordinates, as well as the value, which means I have to do a bunch of prompting to fully create the order. And then for the show possible values, I just need to create the coordinates. So let's take a look at what the order looks like. The order by default is just going to be an action, which is a pure virtual function, which makes this an abstract class, and a default constructor, which does nothing. My order options, I'm just going to call the default constructor here, and then my action is just going to display the possible values, the possible options. For my display board, notice how this constructor takes a board as a parameter, which is going to save it. And then when I display the board, I will be able to display it in the normal way with my action. For my display possible values, I'm going to take the board as well as the coordinates. And then I'm going to save my board, save my coordinates, and then I'm going to get the possible values, display them, and show them on the screen in a user-friendly way. For the edit square, this order is going to be quite a bit more complex because I need to take the board, the coordinates, as well as the value I'm going to plop into there. And then my action is going to get the possible values, make sure that it's legal. If so, I'm going to put that value in that location of board. Otherwise, I'm going to display an error message. And when all this comes together, then I'm going to have an order object. Now, keep in mind, of course, in the case of Q, that'll still be a null pointer. So I'm going to call my executor, which is going to say if I'm not the null pointer, then carry out that action. Because remember, now the order has all the information it needs built into one location. So what is the advantage of that, you say? Well, here's a new version of the same program. And this I'm going to implement undo. So I have my question mark, I have D displayed possible values, H for show the history of all the actions, U for undo, and then of course my edit a square and show possible values. How's this going to be different? Well, let's take a look at how my order has been updated. So now my order has a action just like I had before. It has an undo, which by default does nothing. And I also have a get name, which is a pure virtual function. So for an example, for order options, my name is going to be options. And now I'm going to have my extra parameters in there. For my display board, my name is display board, and I'm not going to have anything special for undo. For display possible, my name is display possible. And of course, I'm not going to have any undo. But for my edit square, now my name is going to be edit A1 with 0 or 5 or whatever else value I'm going to put in there. And to undo, I'm going to take that coordinate and put the 0 element, which clears it. So now I'm going to be able to do undo and show my history of all my possible actions. So going back to my interact, I'm going to have a vector of orders. And then I'm going to allocate a new order option, a new board. History, I'm going to go through all of my orders and say for each one, show me the name. So I'm going to be able to show my full history. For undo, I'm going to make sure I'm not empty. Then I'm going to call the undo and then delete that order. And for everyone else, I'm going to execute the order, push back the order onto my collection of orders, and then continue the process. So now we can see that by encapsulating an action into an object, I can now do undo, I could do redo if I wanted to, I could display my history, and all these things were impossible to do with direct invocation because I had no way to represent an order as a noun, as a variable. Instead, they were just function calls. Okay, so let's execute the encapsulated invocation to see how it goes. I'm going to hit play, build succeeded. Where's my board? Board.txt. And it's going to show me my possible options as well as the board itself. So I'm going to edit and I'm going to say in E5, I'm going to put the value 8. I'm going to edit. I'm going to say H2. I'm going to put the value 7. I'm going to say, show me the possible values for B8. Looks like there's only one 8, so I'm going to say edit B8 is going to have the value 8. And when I display the board, we're going to see that I added something here, added something here, added something here. If I say history, then apparently I edited E5 with 8, which is right here, H2 with 7. I displayed possible. Then I'm going to edit B8 with 8 and I display board. So I'm going to undo display board, undo the edit, undo display possible. I'm also going to undo the H2. Now, if I show my history, it's just going to have one element, E5 and 8. And when I display it, sure enough, that's the only one, so it worked. So back to our original structure chart. Now I'm going to have show history and I'm going to have undo, which is going to add an interact, which gives me a whole level of richness that I did not have before. So now we have yet another way we can pass an order, and we're going to use the interpreter. And the interpreter is a methodology of sending commands between components through a shared language. And it's really up to the programmer to invent this language. What I want to do is encode the order within the shared language, and the executor interprets the order from a collection of actions. So what's this shared language look like? It turns out we have a lot of examples. For an example, I can make it numerical, like 3 does one thing, 1 does something else. I could just have a bunch of numbers. I can have textual, for an example, the simple mail protocol, hello, mail from reception to. All these are a simple textual where I have a collection of known protocols. I can pass them as parameters. This is a command prompt when you want to directly interface with the file system. I can also go parse. For an example, this is Smith notation for chess, where every one of those D2 to D4 is going to be the source and destination, and any other special things like capturing pieces or en passant or things like that. My order could be even more complex. For an example, I could use something like JSON. Here I'm encapsulating the order in a collection of parameters, and this whole thing gets encoded into a big text stream. And I can even use a context-free language such as SQL. All these are examples of encoding orders in a textual format. So what format am I going to use? Well, for option, I'm just going to use a question mark. For display the board, I'm just going to use a D. For the show possible values, I'm going to say show and then where D1 or show where D7 for the possible values for E7. And for my edit a square, E is my specifier, A4 is the location, and what am I going to put in A4? The value 8, or I'm going to put the value 3 in G7. So let's take a look at how we're going to implement that in the code. Okay, on the left-hand side, I have my encapsulated invocation where my order is an object. On my right-hand side, now my order is going to be a string. So if these are types of question mark, my order is going to be a question mark. A D, it'll be a D. E for edit a square, I'm going to have to prompt the user for the coordinates as well as for the value. And then I'm going to create an order, edit B7 with the value 6 or whatever. For when I want to show possible values, I got to get coordinates and then say S is going to be show for possible values. And then I'm going to create my coordinate like D6 or whatever. Now, how am I going to execute this? I'm going to say, hey, if the first slot is a question mark, then display options. The first slot is a D, then I'm going to display the board. The first spot is an E, then I'm going to find the column and row, find the value, and then assign that value to that location. If it's S for show possible values, I'm going to get the column and row, and I'm going to display possible at that coordinate. Okay, so the right-hand side, we have our regular interpreter. On the left-hand side, I'm going to add a couple more options. Show my history and perform undo, just like we did with encapsulated invocation. For the show history, all I got to do is walk through all the order in the collection of orders and display it on the screen, because now I'm going to have a vector of orders. And then every time I execute one, I'm going to push it back onto my collection of orders. And then perform undo, then I have to make an undo function, which is the opposite of the execute. So my execute is going to say, hey, question mark or D or E or S. But for my undo, the only thing I'm going to undo is editing a square. And then I'm going to fetch the column and row from the location, and then I'm going to set that spot to 0. So let's demonstrate the interpreter with undo and redo. So I'm going to run the program. My board is going to be board.text. I'm going to edit a square. I'm going to edit E5, and I'm going to put the value 8. I'm going to edit B8, and I'm going to put the value 8. I'm going to edit H2. I'm going to put the value 7. Those are the ones I did in my previous demo. I'm going to show me the board. I'm going to display the board. And sure enough, I have those values in there, so everything works right now. I'm going to show me the history. So hang on a second. How do I show the history again? Oh yeah, H for history. And so it looks like I made those 3 edits. I displayed and I did a history. Cool. So I'm going to undo the show options. I'm going to undo the display board. I'm going to undo those 2 edits. And now when I show my history, I only should have 1 element. And when I display it, then sure enough, only that value's there. So everything worked. We can learn more about delegate invocation, encapsulated invocation, and the interpreter in the command passing chapter of the software design textbook.